Now see this question, students, here. Very simple to understand, all right? See now, this is a function which is given in the problem. This is a polynomial expression whose answer is equal to 0, it seems. The first term or the last term here, that is the coefficient x, coefficient of x is not equal to 0 is told in the problem, n greater than or equal to 2, has a positive root at x is equal to alpha, has a positive root at x is equal to alpha. Now if you all carefully observe here, if I consider this function to be f of x, then this function will be definitely f dash of x, correct or not? The differentiation of f of x with respect to x will be this part now, if you can agree with me, yes or no? So and also has a positive root for x is equal to alpha. Now if you consider that f of alpha, okay, since alpha is a root, let me say like this, since alpha is a root, I can say that f of alpha is equal to 0, correct? Also tell me what happens if I put x is equal to 0. If I put x is equal to 0 here, also the answer is equal to 0. Is it correct or not? So now by Rolle's theorem, now we can go by this part. By Rolle's theorem, there exists some c belonging to open interval 0 comma alpha such that f dash of c is equal to 0. F dash of c is equal to 0. Now if you consider a root, where is the root now? It has to be between 0 to alpha, right? Now if you basically see, this is nothing but f dash of x. What is the value of f dash of c? F dash of c will be equal to n into a n into c to the power n minus 1 plus n minus 1 into a n minus 1 into c to the power n minus 2 plus so on up to plus a1 should be equal to 0, means the positive root must be definitely less than alpha, right? Which is less than alpha is the answer to the question, because the value cannot be equal to alpha. It has to be always less than alpha because it is in the open interval now. C value cannot take a value greater than alpha. It has to be less than alpha is the answer to the question.